Okay, welcome to electrical machine lecture. Uh, we will do some example. So this is the example. A DC shunt motor runs at 900 RPM from 460 volt supply when taking an armature current of 25 ampere. Calculate the speed at which if it will run from 230 volt supply and armature current of 15 ampere. The resistance of armature circuit is 0.15 ohm. Assume the flux per pole is flux per pole at 230 volt is decreased to 75% of its value at 460 volt. So here uh, the DC shunt motor is there. Uh, DC shunt motor in such a way that in the first case the motor is excited. The motor is excited from 460 volt. So the motor is excited at by the 460 volt. So this is DC shunt motor. Whose armature resistance is 0.15 ohm and it is excited with the voltage is 460 volt. So during that time, the armature current is 25 ampere. The current in the armature circuit is 25 ampere. Okay, and in the second case, the motor is excited by 230 volt. So we'll write here in such a way that when motor is excited by 460 volt, the motor runs at 900 RPM. Let the flux phi1 at 460 volt terminal voltage. Okay, so this is given. Now, when motor is excited by 230 volt, let flux is phi2. Okay, it is given that flux phi2 is 75% of phi1, means phi2 is equal to 0.75 phi1. Only this is the small twist is there. Rest of the numerical is very simple. So we can calculate the back EMF. EB1 is equal to V minus IA1RA, which is equal to 460 minus the armature current is given as for the armature current is 25 ampere. 25 multiplied by 0.15, and it is equal to 440 volt. So we will write here, say for our simplicity, V1 is equal to 460 volt and V2 is equal to 230 volt. Okay. So now this is EB1 is equal to V1 into I1 or A1. Similarly, EB2 is equal to V2 minus IA2 RA, which is equal to 230 minus 15. So armature resistance is given how much? Where armature resistance is given point, so it is not a point, it is point, sorry, this is 0.8. Armature resistance is 0.8. It is 0.8 ampere, 8 ohms. So it is also equal to 0.8, and here it is 15 into 0.8 equals to 218 volt. Okay. Now for the DC shunt motor, N2 upon N1 is equal to EB2 upon EB1, here phi1 upon phi2. So it is N2 is equal to N1 N2, or we will put the value of speed here. It is a 900 RPM multiplied by EB2 218 divided by 440 multiplied by the flux is phi1 and flux phi2 is 0.7551. So phi1 get cancelled. So this phi1 get cancelled, and speed N2 is equal to 594.5 RPM. So this is the answer. So this is the, now the next numerical, a DC shunt motor has an armature resistance of 0.5 ohm and runs at 1200 RPM. So here armature resistance is given, it is 0.5 ohm, whereas speed in the first condition is 1200 RPM and armature current IA1 is equal to 80 ampere. If the torque remain unchanged, so TA1 is equal to TA2 remain unchanged, find the speed, means we have to know or determine the speed when the field is strengthened by 25%. Strengthened means it is increased by 25%. It means that let the initial flux per pole is phi1. The field is, or the flux is strengthened by 25%. That is, flux phi 2 is 25% greater. So 1.2551. So now torque is same. So for that, when torque remains unchanged, that is IA1 is equal to IA2. Simple. The flux torque is directly proportional to flux. Okay. So here the flux is not constant. So we will write torque is, here we will write phi 1 IA1 is equal to phi 2 IA2. So now put the value of fluxes. Here it is a phi 1 IA1 is equal to flux 1.25, sorry, 1.25 into flux phi 1 into current IA2. So this is flux get cancelled. So IA1 is equal to 1.25 into the current IA2. So IA1 is given as it is IA2. Therefore, IA2 is equal to, so 80 divided by 1.25 equals to 64 ampere. So the current, we come to know the value of current. Now back EMF, EB1 is equal to V minus IA1 RA. So it is equal to 250 volt minus 80 into zero point 0.5, so 210 volt. Similarly, EB2 is equal to 250 minus 64 into zero point 0.5, so 218. So before calculating the final result, from our concept here, the field is strengthened, means the flux has been increased. So when we increase the flux, definitely the speed is direct inversely proportional to flux. So its speed should decrease to the previous value. So if our initial value is 1200 RPM, the answer should be less than 1200 RPM. So N2 upon N1 is equal to EB2 upon EB1 into phi 1 upon phi 2. So here N2 is equal to, N1 is 1200, whereas EB2 is the 218 volt divided by 210 volt into flux phi 1 divided by 1.25 phi 1. So phi 1 get cancelled, and speed N2 is equal to, it is 996 RPM. So it is a field control method where the field is strengthened, field is increased. So definitely when we increase the field flux, so the total speed is going to decrease. So next example is 230 volt DC shunt motor runs at 800 RPM with no external resistance in the field or armature circuit. So without any resistance, external resistance added in the armature circuit and field circuit, so the DC motor runs at 400 RPM. So here voltage is 250 volt, whereas speed in the first case is 800 rpm. No external resistance at no load condition. Determine the resistance to be placed in series with the field. Means it is a field control method where we have to put some resistance. We are putting some resistance in series with the field winding. So this is the DC shunt motor, and we have connected external resistance R. This is RSH resistance, so that the motor speed should decrease by or increase to, definitely when we are inserting some resistance, so the speed of motor is going to increase from the previous value. So here N2 should be, or it is should increase up to the 950 rpm, where armature resistance is 0.4 ohm and shunt field resistance is 160 ohms. So this is given. So uh, we will calculate anything is here. Yes, armature resistance is given. Here the torque, change in the torque is not given. So we consider that the armature current IA1 is given. IA1 is 20 ampere. So if the relation of torque is given, then and then it is possible to find out the current in the second case. Okay, so here the torque is not going to change, only this one. So we consider that here, as the armature circuit remains unchanged, hence IA1 is equal to IA2. Okay, so, or it is given. Yes, torque is a 250 volt, no external resistance field, and determine the resistance to be placed in the field circuit so that the motor may run 950 R at armature current of 20 ampere, isn't it? So what we will do, we will consider that the torque will remain same. So let torque will remain unchanged. So TA1 is equal to TA2, and the torque is directly proportional to flux into armature current, flux phi1 into IA1 and flux phi A2 into IA2. Okay. Now this flux is replaced by ISH1 IA1 is equal to flux. It is can be represented as ISH2 into IA2. Okay. So what is ISH1? ISH1 is 250 divided by, right here, ISH1 is equal to 250 divided by 160 ohm So it is 1.563 ampere, whereas ISH2 is equal to 250 divided by 160 plus some external resistance R, isn't it? So let it is equal to 250 divided by total resistance RT, isn't it? So the addition of these two one. So we can calculate IA1 IA1 is equal to IA1 is equal to, if you put the values, means the flux, the current is 1.563 into IA1, where IA2 is equal to 250 divided by RT is the, and the current IA1. Okay, so it is ISH2 into IA2. Now, after putting the value of the current IA1, we can calculate anything is more is given. Yes, in the second case, and armature current is 20 ampere. So in the second case, armature current is 20 ampere. So anything is, yes, IA2 is 20 ampere in the second case. IA2. So here we can say that IA1 is equal to 250 divided by RT into 20 divided by 1.563. Therefore, it is equal to 3198 divided by resistance RT. Okay, so this is the armature current. Now, back EMF 1 and back EMF 2. So EB1 is equal to 250 minus armature current. This is 3198 divided by RT into armature resistance 0.4, which is equal to 250 minus 1279 divided by resistance RT. This is the back EMF in term of unknown resistance RT. Now back EMF 1 in the first case, so 250, this is the first case and this is the second case. So 250 minus 20 into 0.4, which is equal to 242 volt. Now N2 upon N1 is equal to EB2 upon EB1 into ISH1 instead of flux ISH2. So here we can put the values 950 RPM, 800 RPM is equal to back EMF in the first case is 242, whereas the back EMF in the second case is 250 minus 1279 divided by resistance RT into current 1.563 divided by the total resistance 250, total voltage, divided by RT. So this is one. Now, if you solve this equation, we after simplification, it become 296.8 into bracket 250 total resistance RT minus 1279 equals to 378 resistance RT square. So it is a quadratic equation. By solving the quadratic equation, quadratic equation, resistance RT is equal to 191 ohms. Therefore, external resistance R is equal to RT minus RSH, which is equal to 31 ohms. So in this way, we can solve the numerical based on speed control. Thank you.